The Deep Exploration Technologies Cooperative Research Centre aims to revolutionise the way drilling and mineral exploration are undertaken. Conventional drilling is time-consuming, expensive and poses many risks. Here, heavy equipment is helicoptered to a remote site at high cost. Access to the remote site presents safety hazards and road construction impacts the environment. Typically, the process involves drilling holes utilising a drill bit at the end of a string of 3 or 6 metre steel drilling rods. As the drill hole progresses, additional rods need to be added. This process is time-consuming, repetitive, costly and hazardous. A large number of holes may be required to determine the size and shape of an ore body. Drilling many holes also leaves behind a footprint of drill pads and access roads that require remediation or rehabilitation. It can also have a social impact in local communities, especially those close to population centres or remote rural villages. Much of this drilling is ineffective drilling in barren rock overlying the deposit. There is a high cost for consumables such as fuel, water and drilling fluid additives. In addition to the rock samples sought, drilling also produces waste materials that need to be stored or disposed of, including drilling fluids and fine rock powder. It occasionally results in accidents due to continually handling heavy pieces of steel pipe. The Deep Exploration Technologies CRC's vision for drilling in the future is to drill multiple deviated holes from a much reduced number of more accessible drilling platforms. In this example, coiled tubing drilling utilises a continuous flexible drill string, which is steerable using downhole motors and downhole navigation. Drill holes may be stabilised using coatings or casing while drilling technologies that need to be developed. The challenges are not insignificant and will be the subject of research by the Deep Exploration Technologies CRC. The dashed white lines represent downhole information that will be collected by a new generation of sensors gathering rock property data in real time. This data will be transmitted up the drill string and off-site, where it's processed at a remote location, anywhere in the world. Ultimately, it is expected that this logging will remove the need to collect rock samples for off-site analysis. Logging will also involve geophysical sensing of the formation beyond the drill holes, seeking near misses. Potential extensions to the ore body are then modelled and used to plan new drill holes, testing extensions to the ore body. This type of drilling will also allow targets to be tested that are currently inaccessible. These targets include deep targets under population centres or concealed beneath deep cover or natural features such as lakes, rivers and close to coastlines. The benefits of this new technology are significant. Real-time information will enable the exploration program to be modified as it proceeds, removing the need for multiple drilling campaigns. Costs will be reduced as a result of optimising the drill pattern, reducing over-drilling and consumable costs. There will be less impact on the environment, including lower emissions, fewer access roads, and less drill sites to be cleared or constructed. The social impacts of exploration, especially around heavily populated centres and rural farming communities, will also be reduced. And finally, the safety risks associated with manual handling of drill rods will be alleviated. Ongoing collaboration between the exploration and mining industry, drilling companies, drilling service providers, and the Deep Exploration Technologies Cooperative Research Centre is the key to unlocking the next generation of mineral discoveries.